I want to introduce a new type in Python. It's called list, and like the name implied, it's a list. You could have numbers in it. You could have character values in it. So we're going to start a list of last names, and let's let's throw one in here. And let's throw in. Let's make it more interesting. Let's throw in some more names. And let's do at least two more names. So what I'm doing now is I'm just getting a list of names. We're gonna start with four. It could be more. It could be less. But what Python lets you do with list, it lets you kind of organize and keep together a variety of variables that we put into this list, and it's incredibly handy. Okay, so we have a list called QB. We have put in there four last names: Tannehill, Rogers, Carr, and Newton. Now, that's how you create a list, but to print from it or reference it, we can just look at we put the list name in the index in the list. The one kind of confusing thing about this, the first item in the list is 0. You'd think it'd be 1, but it's 0. And as long as you know that the first item's always 0, you should have no problem working the list. So what this is saying is to go to the QB list and put the item that's in index 0 and print it out. So let's run this. This runs, and we get the first name. So likewise, to print in the one with that 0, we can print 1, and the 1 should give us the second last name in the list. Let's run this, and indeed it did. We have Tannehill and then Rogers. This is very good, and great way to keep track of things. And let's get a little more. Let's do some more things with this. Let's assign a string. We call it my string, and let's use elements of the list. So let's use the QB list, and let's go for index 0, and we're going to go add it or concatenate it to the string. Let's go verses. So we're going to put some verbiage in there, and then we're going to do some more concatenation with the plus symbol, and we're going to put 1. Okay, so my string should contain the first item in the list, space, and versus the second item in the list. So let's see if this works. And a good way to see if any of your actual assignments actually work is to print them out. So we're going to print out my string here. Okay, let's give it a run. Okay, there's a 0 item and the 1 item, and then what we do here, we concatenate the 2 items in the list with another string item, and we have Tannehill versus Rogers. Okay, now there's also a, a some useful things you could do with strings. So if we go qb dot append, in the append will let us add to the list. So for say we wanted to add add some to the list, we can go ahead and do that. So let's add something else to the list. Let's add another name to the list. And so now the list has grown. Instead of 4 items, once we run that, there should be 5. So let's print out the new item once we append it. So we're gonna go here and let's say 0, 1, 2, 3, 4. So we would think our new item will be at this index. So let's run it. And indeed it is. Now, in addition to the add, the append, which puts it at the bottom, there's insert, and the insert's kind of cool because the insert lets you basically insert it anywhere. So we're gonna say insert at the 0 position, and we're going to put another last name. And so what this insert's going to do is it's going to insert this last name into the list in the 0 position, which is the first position, and basically push all the items up in the list, kind of shift them over. So what was in the 0 position after this would be the 1 position, and so on. So we're going to verify that once we insert this to the 0 position, it is indeed the 0 position, and what was the original 0 position is now the 1 position. So we're going to run this. And indeed, now we have the item from the original first or 0 position is now the number 1 position, and the new inserted item is the 0 position. So let's look at some of the other kind of cool things we can do here. And let's go for the remove. We want to remove someone. So let's go to our list, type into our list, and then dot remove, and now we can pick a name from the list, and we're gonna go with car. So this should have removed, or should remove, car from the list. So we run that. We didn't print that car was removed, so let's do that. Let's go ahead and after the push up, car should have been he was 0, 1, 2, but we put another person in there, so he should have been 3. So let's go check that out. So we're going to run this again and see what's in the 3rd position. and it says Newton. So we did indeed remove car. He no longer is in the list. Now, another interesting thing there. So let's go and let's try to find the location of a name. So we're going to go LOC for loc. I mean, that's whatever name you want to call it. You could say my location. We would call it that. So my loc. And we're going to go equals QB index. So the index will tell us the position in the list of whatever we're looking for, and we're going to look for Newton, and we're going to see where in the list Newton is, and then we're gonna print. Okay, that looks good. So what it did was it told us that Newton was in the third position. So these things can be really useful when you're writing logic to look for missing people on the list, to do lots of things. So the very useful stuff that we can do in Python. But let's say that we had some similar, but instead of Newton, we're going to look for car. And we know that we removed car, so car shouldn't be in the list. So when we run this, it's going to run, it's going to say the location of Newton, and then it's going to hit the section and give us a value error saying that, well, car's not in the list. And we really don't want to show value. We don't want our programs to crash in this way. And a really cool way in Python to avoid this is with a if. So let's see if we could kind of encapsulate this in a if and make a safety net. So we're going to go if car in QB. So what's really cool about that n, Python looks in the list. It would look in this list for us, which is, I mean, really helpful in many ways. So if that does that, we're gonna do that and then print it. So what we're saying now is if car does exist, we want to find the location index or the index of car, and we want to print it. But if the search is fruitless and finds nothing, meaning that it does not find car in the list, we want it to kind of tell us something. So we're going to go print, and we're going to say not in the list. So what we're doing here is with an if statement and using n, we're able to scan the entire list, look for car, and if for whatever reason we don't find car, we're not going to error. We're going to just print not in list. But if car is found, we're going to assign my location equal to where car was, and then print that. So let's run that, and we're getting a lot of things up here in the list. So I'm going to give it a little move over there to keep clear what we're doing. Okay. So what had happened here was it's just not in the list, because indeed car is not in the list. And if we were to try it with someone in the list, let's go find someone that we appended to the list. So let's make some changes here. Let's change car to Stafford. And we're going to run it again. Okay, so you see this time it looks for another last name in the list, and it says indeed the last name is within this list. It's going to execute this block of code, which gets the index and puts it in my location, and then prints out saying that the index is 4, and this else is never executed because we did find what we were looking for in the list. Another interesting thing to understand about list is that they're a mutable type as opposed to an immutable type like int, string, float, or bool. And this primarily comes into effect when we pass them to functions. In the functions you've seen in the past, we send off a value. The value itself never gets changed. We create another value within there, and then we send a return. We return this value, and then there's some sort of assignment going on with that. It's because in those functions we can't change the value of a string or int or a float that we pass it within the function. Not so much with list. Lists can be changed, and that's what mutable means. So when we have a list we throw off to a function, it's going to behave differently. We pass it and we do all the changes in the actual function to the list. We don't have to pass back a return value or anything. So if you were to look at list functions, you wouldn't see a return value. They're more just like sections of code operating on a particular list, or multiple lists if you have multiple lists in the argument. So that's just something to bear in mind. I wanted to talk about another data type, tuples. You don't see as much in our text or in most text about tuples, and a lot of people that use Python for smaller projects don't use them at all. You may never need to use them. They're basically a form of list that is not mutable, totally immutable, and it's very difficult to work with because all those nice like add, remove, and that's not there at all. You have to totally define the entire tuple, or essentially the whole list, every time you want it changed. And for most applications, it makes these difficult. A lot of people feel they're unnecessary, but they do have a value, and the value is speed. And in smaller programs, you don't have that. But if you're doing large data, like for large insurance company, federal government, and you may be processing millions or billions of records, time is very important, and speed is very important. and tuples can be very, very important. What I want to do is give you a quick rundown on how to define them, and we're just going to use what we have here, do a little modification to it, and we're going to call it QBT, and change it to parentheses, and now that defines a tuple, and we can refer to them in a similar manner before. So let's run this, and so it essentially looks the same because we defined a tuple. Now we're referencing that from them, but you can't change them. So like if we were to try the pinned on there, and it's going to say no, we can't do that. So for most smaller programs, I totally avoid tuples because you have to redefine them all the time. You can't do any of these slick things with them. But for maybe you have a set of business rules that is a million or a billion actual items, and you throw that in there, and the speed that Python can process through that is incredible amount faster than it can do with a list. So I guess the thing to bear in mind is to know that tuples exist, and if you're dealing with large amounts of data, like I said, federal government, various large insurance agencies, things that don't change a lot, things you can basically read in once in reference, tuples is the way to go because it will give you speed, but you just don't have kind of the niceties and the being able to change on the fly, being able to update and remove and do all the things that you can do with a list.